Hello, statistics scholars! This is our first lecture for Chapter 11, Two Related Samples T-Statistic. Here are the learning objectives for Chapter 11. This is what we're going to cover, and this is what you will need to know for the next proctored exam. Think of these learning objectives as your roadmap through the chapter and your study guide for the next exam. So take a minute, read through these, In this lecture video, we will discuss related samples design and related samples hypothesis testing. This t-test is not as complicated as independent samples t-test. In our last chapter, we introduced a hypothesis test for situations when we observe independent samples. An independent sample is one where different participants are observed one time in each group. So we collect only one observation or score per participant. We can select two independent samples in one of two ways. We can select a sample from two different populations, or we can select a sample from a single population and randomly assign participants to two groups or conditions, as was described in the previous chapter. In this video, we describe a hypothesis test for when we observe related samples, samples where participants are observed in more than one treatment or matched on common characteristics. There are two types of research designs commonly used to select related samples: the repeated measures or related samples design and the matched subjects or paired subjects design. These designs are analyzed in the same way, however, the data are collected differently for each. The most common design is the repeated measures design or within subjects design. In this design, each participant is observed twice, once in each treatment. We can create repeated measures by using a pre-post design or a within subjects design. Using the pre-post design, we measure a dependent variable for participants observed before, pre, and after post a treatment. For example, we can measure athletic performance, that's the dependent variable, in a sample of athletes before and after a training camp. We can compare the difference in athletic performance before and after the camp. This type of repeated measures design is limited to observing participants two times, before and after a treatment. Using a within subjects design, we observe participants across many treatments, but not necessarily before and after a treatment. For two samples, let's say we want to study the effects of exercise on memory. We can select a sample of participants and have them take a memory test after completing an anaerobic exercise, and again after completing an aerobic exercise. In this example, we observe participants twice, but not necessarily before and after a treatment. Anytime the same participants are observed in each group, either pre-post or within subjects, we are using the repeated measures design to observe related samples. Here are some more examples for repeated measures design. 1. Are reaction times different with dominant hand versus non-dominant hand? 2. Are wait times at amusement park rides reduced after implementation of new loading and unloading procedure? 3. Does BMI decrease after bypass surgery? The matched subjects or matched pairs design is also used to study related samples. In this design, participants are selected and then matched experimentally or naturally based on common characteristics or traits. The matched subjects design is limited to observing two groups, where pairs of participants are matched. In a matched subjects design, different but matched participants are observed in each treatment, and scores from each matched pair of participants are compared. We can obtain matched pairs in one of two ways: experimental manipulation or natural occurrence. Matching through experimental manipulation is typical for research studies where the researcher manipulates the traits or characteristics on which participants are matched. We can match pairs of participants on any number of variables, including their level of intelligence, personality type, eating habits, level of education, and/or sleep patterns. We could measure these characteristics and then match participants. For example, we could measure level of education, then match the two participants with highest level of education, the two participants with the next highest level of education, and so on. Matching through natural occurrence is typical for quasi-experiments, where participants are matched based on pre-existing traits. Pre-existing traits are typically biological in nature. For example, we could match participants based on genetics, like biological twins, or family affiliations, like brothers, sisters, or cousins. Each trait or characteristic is inherent to the participant. There is no need to measure this in order to pair participants. Pairs of identical twins or brothers, for example, are paired together naturally. Here are more examples of matched subjects designs. 1. A researcher wants to know if mean length of stay in for-profit hospitals is different from mean length of stay in non-profit hospitals. They randomly select 20 individuals in for-profit hospital and match them with 20 individuals in a nonprofit hospital by diagnosis. 2. A prison warden wants to know if men receive longer sentences for crimes than women. They randomly sample 30 men and matches them with 30 women by type of crime committed and records their lengths of sentence. The related samples hypothesis test follows the same 4-step procedure we outlined in Chapter 8 and in our previous chapter on independent samples. Step 1, state hypotheses. For related samples t-test, the null hypothesis states that there is no mean difference. On this slide, I have provided the hypotheses for upper-tailed tests, lower-tailed tests, and two-tailed tests. Step 2, set the criteria. Select alpha level, and in our class, this will always be given to you. Locate the critical region. The t-critical values for the t statistic are obtained using degrees of freedom, alpha, and whether the test is a one-tailed or two-tailed test. The degrees of freedom for related samples t-test are the same as degrees of freedom for one sample t-test. Degrees of freedom is equal to n minus 1, where n represents the number of difference scores. Related samples t-statistic is structurally the same as one sample t-statistic from Chapter 9. Related samples t-statistic is based on difference scores d, instead of raw scores x, or sample means m. So to prepare for statistical analyses, we need to calculate difference scores, or the difference between first and second scores. Difference scores are d equal to x2 minus x1. Our analyses will be based on these difference scores, ignoring before and after data or paired scores. We calculate a mean of difference scores by adding the difference scores and dividing by n, where n represents the number of difference scores.